Hello there. Good day. I hope you are doing well and you've been staying safe. I welcome you to the video version of MA 280, that is computer appreciation, where specifically we are dealing with programming with R software and as well as MATLAB. Now, from the beginning of the semester, we took a look at Introduction to R. That was the chapter 1, where we got to see how we could download the R software, install it on Windows because most of us are basically used to the Windows operating system. We also got to expose ourselves to the R Studio, which happens to be an IDE, that is an integrated development environment for R. We also get to know what R packages are and how to install them and how to load them before you can make use of these packages. Now in chapter 2 we also got to do one or two things with R, that is the basic concept in R, where we did some basic mathematics. We got to know what a working directory is, what variables are, data types, and the rules of assigning variables to any object that you can locate in R. We also talked about dates, logics in there. And in chapter 3, we got to see some advanced data structures where we got to know of the vectors. Within the vectors, we got to play with numeric vectors. We also saw how to generate sequence, repetitions, levels, and extracting elements from vectors as well. In there, we also came along the matrix, which happens to be one major data structure in R or major programming languages. We also got to see how to access elements from these matrices and as well as arrays, data frames, and data frame, that is one major thing. And with this data frame, we shall be using this a lot. We shall be coming across this a lot, and that is also one thing we are bound to even experience once we get to the field of work. You guys will see this more often. And in chapter 4, we got to see how to read and write data in R. Now, reading means you are trying to import data, but if you are trying to export data out of R, that is where we use the term write. And we got to do so many things: how to read data in CSV, in TST, also how to access data from websites, and once you are done with all your analysis, that how you get to export them using the write function. Also, yeah, so with that knowledge that we've acquired so far, we are going to base on that to move on to the next chapter, that is chapter 5, where we get to do some basic statistics with the data. Now we are able to import into our system. So with that said, we shall move straight to chapter 5 and we continue from there. All right, so chapter 5, that is basic statistics. Now we all know the relevance of these basic statistics, and even in the first year you guys were introduced to basic statistics. I mean in problem start 1, where you go to do so many things. Now one thing that you observe from those times or those lectures is that basic statistics say so many things about the data at hand. I mean, it gives us so much information about the data at hand, and with these graphs or with this statistic that we get out of this data, we can base on that to give out meaningful decisions and all that. So in R, we are going to demonstrate this instead of we getting to draw plots by our hands, and that this time is going to be made easy by the use of the R software. So we are going to take use of that. So in that regards, let's go straight to our R, where we are going to import some random data and just try that. Okay, yeah. So this happens to be a R, and this is our editor. This is our global environment. These are our various options that we could access. And finally, this is our console where we shall be entering most of our codes. Now, all the codes that I have under this chapter, I have typed them in an editor, which is the one that you see here. So I'm going to take you through all this one by one, but for the sake of time and all that, I've written everything. So any code that I'm going to use, I'm just going to pick up right from here and just run it. Okay. So first of all, let's start by, let's say, generating a random sample of, let's say, 100 sample points or sample observations. And let's make it a little bit interesting by increasing this to 1000. And you should know that any code that you see here is in your lecture material, so you don't have to be in a hurry to type all or copy all this. Okay, everything you see in here is in your lecture material. So with this first code, I'm trying to generate a sample that is from 1 to 1000, but from that 1 to 1000 I need only a size of 100. So I'm looking for 100 points within 1 to 1000, and this replace true that we have here, meaning that I can have multiple points at once. So once I run this code, it has been given me. So anytime I call for this variable x, so that is the sample size I see right up here. Let me shift this up a little bit. Okay, so this is my 100 data points, and this is what I'm going to do my analysis on. Now, from our basic statistics, we go to know of a very popular term, that is the mean or the average, where you get to sum all this divided by the total number of observations. This is done with a simple function, that is the mean, and I just specify the variable. So mean of x, that is the variable that I just generated, that is the 100 observations, and this is just going to give me a mean of 522.58. So if you were to take your calculator to work this, which is going to take you like should I say more than 5 minutes, you arrive at this answer, and that is easy done by R. Now, one more thing that the world is always not so perfect. At times you can come across a data which might have some missing numbers or missing data points. So in that, let me try to introduce some into my data points that I have here. So suppose that this, hypothetically, I generate, or let's say I decide to replace 20 observations of my variable x with random, or let's say missing numbers. So in this case, with my sample that I have, I'm trying to inject some about, let's say, a size of 20 missing numbers. And once we talk about missing numbers, that is best represented as NA in R. So in this case, I'm just going to replace most of these, about 20 of them, with NAs, and that is the code that I'm running here. So in the first case, I'm just going to assign x to y, and that is that. And in this second case, I'm just going to replace about 20 of my points in here with NA, and in doing so, this is what I get. And anytime I call y, so you can see that I do have some NAs in there. Yeah, they are just about 20. And let's see, so if this was to post, this was a raw class or a student in front of me, I would have asked you that what do you think is going to happen when I check for the mean of y. But unfortunately you guys are not around, so I cannot ask this. So that is that. So you, out of curiosity, let's run this and see what happens. Now you can see that we are getting a mean of NA. Why do you think so? Because we do have some errors or some elements which are not numeric in our data. And for that matter, mean is definitely going to give us an NA. But let's watch it. Before this can work, yeah, definitely we can find the mean of y. But in that case, we also have to introduce another argument, that is the NARM, that is remove all NAs, that is an argument for that. We did talk about this during our, I think, our chapter 4, that is NA.rm equals to true. So once we specify this argument, it means that um, R should ignore all the NAs and just calculate our mean. So once we do that, our mean of y now becomes 526.8375. So with that, we can estimate our mean. Another popular statistic was our variance, and in that case, or in the case of R, we are going to use var of x. So in this case, var of x, and that is that. Now if we were to go with a normal approach, I mean, we have been taught in class that each observation minus the mean all raised to the power square all over, I think, n minus 1 or something, that is going to give us the variance. Okay, now we can also write this as a formula, and that is exactly as we see here. So this is just going to sum each observation of x and subtract from the mean of x all squared divided by length, that is the same as n minus 1, and that is the mathematical formula for finding one variance. But this is just a long approach, but if you are developing programs and other stuff that you like to go much more into the mathematical aspect of it, you can try using this kind of stuff. But as a short, or as a, there's a function for that, and that is the same as what this var. Okay, so we can also run this formula, and it's going to give you exactly the same thing. Okay, now another popular statistic that we know, that is the standard deviation, which we all know to be the square root of the variance. So we can just use the square root of the variance, and that is just going to give us the standard deviation. But R has a simple formula or a simple function for that called the SD. So once we specify SD into bracket the variable, that is just going to give us the standard deviation of our data set X. In that same case, let's try to play with our data which involve the NAs, that is the Y. So SD of Y, let's see what happens. Yeah, because there's NA included. So let's introduce in the NA, remove all NAs, okay, that argument. So once we do that, we get our SD as simple as that. Now some other statistics like the mean, the max, the median, all these are simple basic statistics that we were taught back at problem start 1, and we could do all this using the mean function. And our minimum value of x was 1, and let's see our maximum, that was 986. Remember that our sampling was from 1 to 986, so that is exactly what we have in here. So we have 1 to 1000, but sampling randomly, R chose from 1 up to as the minimum and 986 to be the maximum observation. It's just a sample, just randomly, so let's go with that. Okay, so that is that. We could also calculate for the median of x, and that is what we see in here. Now we could also estimate our mean of y, but remember they have NAs, so we do have to remove all our NAs, and that is that we get as that. Okay, now looking at all that we've done, starting right from the mean, the variance, the standard deviation, the mean, the max, all this could be done with one simple function that is called a summary. This summary is just going to give us the entire summary of the data, but we might not get to see everything, but it will give us most of the descriptives of the data. So if we should run this summary of x, now we could see that this is giving us the mean, the first quartile, the median, the mean, the third quartile, and the maximum. We did not see the SD or the standard deviation. We did not also see the variance, but these are all stuff that we could estimate using their specific functions that we just saw up there. So in that same case, let's see something interesting here. With X we had no NAs, but in Y we had NAs. But let's see what is going to happen. Before I even run, what do you think is going to happen? Let's just continue. Let's run the summary for our Y and let's see. Now let's see what is happening here. You can see that there's also another an included element in here, meaning that summary is also going to sum up all the number of NAs we have. And remember, we specified 20 NAs when we are trying to generate the Y data set. And you can see that exactly we have 20 NAs in our data set, aside all the other stuff, that is the other statistic that is being included here. So that is that. Now someone is going to ask, how do we get to calculate for our third quartile, our fourth quartile, and all that? That is third, first quartile, and our median, which is the same as the second quartile. Now we can do that using this function called a quantile. So once we specify the quantile, we specify the data set in which we are interested in estimating this quantile, and we specify the probability. Now suppose that we are only interested in the 25th quartile, which is the same as the second quartile, which is 25th quartile. That is exactly what we have here. So all that we have to specify is the 0.25, representing about 25, or let's say the 25th. In that same case, if we want the 75th, that is exactly what we have here. Okay, so in doing so, if we could run this, this is just going to give us the 25th quartile to be 321, and the 75% of the data set. That is, if we should divide the data set into this quartile, the 75% or the 75th position is at around this point, and so that is also that. In that same case, you could also do for remaining sessions. So if you want the 10th, the 25th, the 50th, that is the same as the median, that is the 75th, as well as the 99. You could do all that. Okay, there's no restrictions when you come to this quartile, and with this, R gives you so much flexibility that you can do anything basically that you want. Okay, so remember we talked about this concatenating sign, meaning that if you like to join so many things at a go, you could make use of this concatenating sign, and that is one useful function in R. So we could do same for the Y, but remember with the Y we have some NAs in there, so you would have to remove them with the NA remove. Okay, so that is our quartile, 25th and the 75th for the Y. In that same, we can also do for multiple. Okay, so we have the 10, 25, 50, 75 being corresponding to whatever we have in here. Okay, so that is also that. Before we go there, let me try to shift here a little. Okay, voila. So back in our basic statistics, that is problem stat 1, we also did something very important, that is trying to determine the relationships of between variables and all that. Okay, yeah, so we could do the same thing in R. Okay, where I think back from those days where you have to estimate the summation of y, summation of x, that is variable, then you divide by so many things. It takes so much time, and that is somehow time consuming. But in this, we are going to play with a raw data set that is an economic data of a certain country. I'm not so sure of the country, but I think it's going to be US or something. Yep, so we are going to look at that. So in this, yeah, This is a very special package. This data is being contained in a very special package, that is the ggplot2, and is a very interesting data. And this data set contains so many variables that we can play with. So let's see. We treated how to download packages and how to load them in R. So in this case, the package we are interested in now is the ggplot2 package. So I will entreat you guys to go download this package and you can have access to this data set, that is the economic data set. So I have already downloaded the ggplot2 into my R. So all that I do have to do is just to load this ggplot2 into my system. So let's get to see this ggplot2, and this is just ahead of that data set that is going to give me about 6 observations or 6 instances. So you can see in this data set we have the dates starting from 1967. I think it's a monthly data, and we have the PCE, and the PC happens to be the personal consumption expenditure, and we also have the POP, that will be the population, then the PSAVERT, I believe that will be the personal saving rates of the country. We also have unemployed, and also have unemployment, something like that. Okay, so we are going to just play with this data to see the correlation, that is the relationship between one variable from the other. Okay, in that same case, we could also use the function view to view the entire data set. Okay, like in this more or less like a tabular fashion. Yeah. Yeah, so that is that. Okay, so this is more tabular, that is the full data set. Contains about 574 instances. That is exactly what we have here. Okay, so this is the data set we shall be playing with. Okay, yeah. So in this data set, before we even go down there, suppose we like to look at the expenditure of the country, and as well as the saving rate of the country. What do you think is going to be the relationship between these two variables? That is personal consumption or the consumption, as well as the saving of these people. So before we go down, I'd like you to think about this, like even from your own point of view, that in your life, like you do earn one or two, irrespective whether it's from your parents or from whatever, you get to earn something once in a while. Now, what do you think is going to be the relationship between how much you consume or how much you spend and how much you can save? Now, I believe by now most of you are thinking so many things, but let's see what this correlation analysis does. Now, this correlation analysis, remember that it ranges between -1 and +1. Now, if it is closer to -1, it means that we have a negative relationship, or if we should get a statistic that is between or that is negative, it is being considered to be negatively related to each other. In that same case, if it happens to be a positive figure or value, then that will make it as positively related. But if it is exactly 0, it means that there's no relationship between these two variables. Okay, so in R we are going to use the function COR, or people will call it the core. Okay, so core of, and in this case we are going to specify the two variables that we are looking at. So in this case we are going to specify economics, but specifically we are looking for the what, the PCE data, or the PCE variable in economics data set. Remember, we did something with this dollar sign, that is if we like to go into sub, we make use of what, this dollar sign. Then we specify the second variable, that is the personal saving rate, that is the PASVERT. So economics, but within economics we are interested in PSVAT. Okay, so we are just going to check the relationship between these two, and once we run that, we are getting somewhere negative 0.79285446. And it means that there's, should I say, a strong, more or less like somehow close to a strong negative relationship. And in reality, this is true because the more you spend, the less you can save. Okay, and if you like to save more, it means that you have to what, spend less, and this makes a huge sense, and there's a huge sense in this, and this makes a really lot of sense, you know that. So this correlation is somehow true. Okay, and this somehow true, and it depicts real life situation in here, which is true. So as a try, I would like you to also check the correlation between personal consumption and the other parameters that we had. So you can check with the population, you can also check with the unemployment, and I would like you guys to give me a response on that. So the next time we meet for our video online conference, I will ask for the correlations or whatever you got out from these correlations that you did. That is, try to compare the correlations among these variables that we have. Okay, yeah. Now in that same case, suppose that you would like to compare multiple variables at once. Remember how to extract data set from matrices. Okay, we are going to use the same thing here, but in this case our economic data happens to be a data frame. Okay, and remember the extraction process is basically the same. So in this case we are going to check for the correlation of the economic data set, but in this case we are interested in from column 2 to column 6, and remember column 2 to column 6 happens to be from this point up to what, this point. So meaning that we like to check the correlation from this, excluding the date. Okay, so once we do that, we just run this, and we are getting so many things here. Okay, so just like a correlation matrix. Okay, so we have PC, POP, that is the population. Okay, and you can see various what, correlations out of this. Okay, so that is also that. Now we can also think of drawing a correlation matrix. In this case, we are going to ignore one of the variables in there, which is you can see in this case we have C of 2, that is the second column. In this case we are ignoring the third column, which happens to be population. Okay, so this we are just ignoring what, the third column, then the fourth up to what, the C. And once we do this, you can see in this case we don't have population in here, and it is due to this condition that we made once selecting our number of columns that we have here. Okay, so if you should revisit how to extract columns or data or element from data frames, you should be able to get this point really clearly. Okay, so that is also that. So that is like basically some of the should I say, basic statistics you guys did during the probe and start one course. Now an interesting one you also get to know about this statistic is some kind of hypothesis testing, and in this we are just going to stick to the basic ones, just like the t statistic, the one sample, the two sample, and the others. Okay, so looking at the t test, now for us to do this, we are going to make use of a very nice data set, which is also located in a very special package called the Reshape 2. Now with this Reshape 2, I already have it, so if you don't have it, you have to download that package before you can make use of it. Okay, now this reshape, or within this reshape 2 package, we are going to make use of a data set within there called the tips, and this is how customers would like to tip, I think, the attendant once they visit restaurants and that. So we are going to look at this data. Okay, so we are just going to load in our package. So with this, instead of require, we could also use library and require works like hand in hand, so we could also use that. So let's load our package. Voila, our package has been loaded, and let's see the package or what the data set looks like. So within the tips data set or the data frame, we have total bill, we have the tip, we have the gender of the customer, we also have whether the customer is a smoker, the day, whether it was sunny, whether it was cloudy, they're all in there. We have the time, whether the person came in for breakfast, lunch, or not, and the size. I don't know specifically what the size talks about, but that is also another data set under this tips data frame. Now let's look at it from the tabular point of view, and with this we have so much in there. Okay, so that is the full data set, and it's about, they were able to take data for 244 customers. So that is exactly that we see in there. Okay, so that is that. So going back to our data set, for now let's try to conduct, let's say, a one sample t-test. Wow, it's quite unfortunate that you guys are not here, because I would have asked what a one sample t-test is to begin with. But let's continue, by the way. Now, once we say a one sample t-test, remember from your hypothesis testing course, you could have an instance like what is the average age of a class. Okay, so in that case we have 2 options. It could be that the average class, one might have a hypothesis that perhaps the average age of the class is somewhere like 22. But because we need to test this, there are 2 ways to test this. Whether to go by a one-sided, that is, in that case the null hypothesis or the alternate hypothesis will be, is the average class equal to 22. Now if that happens, it could be that the average class is not equal to 22, which in this case could be less or greater than what, 22, and in that case that makes it what, a two-sided. Now in doing this two-sided, R has it using the function the t.test. Now in this case we are going to use this variable called tip. We are going to test the hypothesis of this data set, that is the tip, and with this tip we are going to test whether the average tipping of the customers is equal to $2.50. Okay, so in this case it could be that our customers or the tipping could be more than $2.50 or less than $2.50, and in this case that makes it what, a two-sided. So in this case, once we are computing this, we will also have to what, include this argument that the alternative is a two-sided one, hypothesis testing, and with that we also have to what, include what, our mu, that is our 2.50, that is the value at which we are testing this hypothesis. So we are going to run this hypothesis, and with this is going to pick up the tips data frame, and within the tips data set or the data frame we are particularly interested in the tip. Okay, so that is that. So if we should run this is going to give us so many things. of which most of them are familiar. Okay, so in this case we have one sample, and remember we are dealing with only one variable here. That is why it's called one sample. So that is the one sample, but our options are two here. It could be greater or lesser than. That is why we have what, the two-sided. Okay, so let's look at it. So in this case we have a t value, which most of you would like to call it the t critical or the critical value. We have it to be 5.6253. We have the degree of freedom to be that, and the p-value to be that. Now this is somehow related to your ANOVA table. Okay, so we have something like this. Now I don't know whether you guys were being taught how to decide or how to make a decision based on a p-value. I know that you'll be taught with the t table and the critical, that is the decision, but the rule or the decision is virtually like the same. Okay, we are going to compare this p-value with our significance level, and in this case our significance level happens to be 5% because we are dealing with a confidence level of 95%. Okay, so in this case our p-value happens to be lesser than 0.05. so in this case, just as using the critical value and that of the tabular value, in this case we are also going to reject the null hypothesis because our p-value happens to be less than our significance level of 5%. So in this case we are going to say that the true mean or the average tip is not equal to 2.5, and that is just going to be our conclusion. Okay, now in that case R also gave us other estimates such as the confidence interval. Okay, so we have the lower limit and the upper limit right here. Okay, so you could use this kind of test for your analysis in the future. I believe most of you doing their project might make or might see this to be very important once it comes to hypothesis testing. Okay, so that is that for a one sample or a two-sided, a one sample but a two-sided. But what if you like to look at a one-sided? So that is when it's either greater than or less than. Okay, so in this case all that we have to just do is specify this argument whether it's greater than or less than. Okay, so in this case we are going to test whether the average tip from these customers is greater than $2.5. Okay, so we are going to just specify greater and here and there's the mean. Okay, so once we specify this, automatically R knows that this is what a one-sided. So once we run this, we are getting this information. So in this case we are getting a t value of that. We're also getting a degree of freedom to be 4.243, and finally a p value to be that. Now if we should compare this to our 5% significance level, we could see that we still have to reject our null hypothesis, meaning that our or the average tip is still greater than $2.15. Okay, and there's something interesting in here. Our confidence level happens to be 2.825, but once it comes to the upper, we have infinity. Now this is your first assignment. I would like you guys to tell me why this is infinity, and this is 5 marks. Okay, so I'll be waiting for the response the next time we meet. So that is also that. Okay, so yeah, so that brings us to the end of our one sample t test. But what if you like to do this hypothesis testing for two sample this time? And once it comes to two sample, it means that we have two variables that we like to compare whether they are equal or they are not equal. Okay, so this is what we are going to do in here. Okay, now this is the general, let's say, argument for testing for t for two samples. Okay, So in this case, you can see that the first one will be the variable, the first variable you are looking at, and the next one happens to be the second variable you are looking at. Now this tilde sign you see here, most of the time we like to call it, like, it's more like it depends on, like tips depend on. That is something we are going to look further in the next chapter. Okay, so if you like to compare these two variables, whether they are equal, all that you have to do is just relate them using this tilde sign. And remember this, instead of this straightforward, we could also specify that all these variables can be located in the data types. That is, data is equal to types. So once we specify this, R can just go straight into the data types and look out for these data. Now, aside this, we could also write this in a different way. But before we go there, let's talk about this argument that we have here. That is the var equal. Now, if we should set this var equal to true, this is just going to run a standard two sample test statistics. But if we should specify that this var dot equal is equal to false, this is just going to run a Welch test. And I don't know, but that is something you guys can read on. That is the Welch test. It's kind of different from the standard two sample statistic you guys were taught in class. Yeah. But before we run this line of code, remember I told you that this could be written in a different way. Now, instead of specifying this data set, we can just put data here, and just as we did to the previous stuff, or just like this, we could specify tips, then the dollar sign, then we do the same thing for sex, and the dollar sign. And once we do that, we can take away this argument from there. Okay, so if we should run this for the first time, we are getting something. So with this t-test, we have a statistic to be negative 1.3879, degree of freedom to be 242, and the p-value to be 0.1665. Now using a significance level of 5%, we could see that this p-value happens to be greater than our significance level. So in this case, it means that we cannot reject our null hypothesis this time, meaning that the true difference in the mean is not equal to 0 will be rejected. So meaning that the true difference between these two variables that we are looking at is equal to 0, meaning that there is no difference between these two variables that we are looking at. Okay, so that is that, and we also have the confidence interval right here. Okay, so that is something that we could make use of once we are doing that. And also looking at the mean for the male and from that of the female, we could see that their mean is virtually close. That is 2.8 and 3.0. Like they are virtually the same. That is why, like, this hypothesis is trying to say that, like, the mean or the difference between them is like virtually 0. There's no significant difference between them. Okay, so students, that brings us to the end of chapter 5, that is basic statistics. And I hope this online video will be very useful to you guys in these times. And before I say goodbye, I'd like you guys to stay safe. Make sure that you stay at home. Still read your books. You know, life must always continue. So always stay glued to your books, and we shall meet here very soon. Okay, so enjoy your day, and bye bye.